Welcome, ladies and gentlemen. So this is going to be the one of hopefully many more troubleshooting videos on how to troubleshoot and fix a computer. I'm just running a test video here to see how well the response is, um, and then we might start up a YouTube channel. So let's go ahead and get started here. We have a rather old system here. Nothing wrong with old systems as long as you take care of them. They keep on chugging. In some cases, better than new ones. So, um, I have been informed. I haven't turned this on or anything. I'm just going to catch you up to date on what I have, the information that I have. The system supposedly powers on, and then it shuts itself off. That's the information I have now. Maybe in a technician, there could be many reasons for that, and we're going to go through them. And we'll go ahead and I've already got it hooked up here, as you can see. Please disregard the mess in the background. We have many projects going on at once. Yeah, projects. There's currently actually 5 systems that I'm waiting on parts for. Anyways, so let's go ahead and do this live, and let's see what she does. So let's go ahead and power on. I've got the power off here, so we'll go ahead and give it power. The system just turned on, and let's see what she does. Well, it's a Pentium D, a little bit of an older system. I don't see any poster marks there. I'll get into that at a later date. Alright, so apparently, right there, that screen tells me that this system was not shut down properly, that there was a critical power failure with this. So let's go ahead and tell it to start Windows normally, like it normally would. And supposedly, I'm going to go ahead and pause this because if there's any sensitive information on this person's desktop, I do not want to have that in the video. Got my finger over the pause button. This is also taking a relatively long time to boot here. It is an older system, so I'm going to go ahead and pause this and wait till it gets on the desktop. Okay, it's been about 3 minutes now. This is taking an excessively long time to boot. Generally when this happens, we'll just put it in the back of our minds to make sure we run some tests on the hard drive to make sure that's in good, healthy shape. Because if that's not, that would be a prime reason for it to shut off. If the hard drive has errors on it and the operating system can't run correctly, it'll run what's known as a blue screen of death, where the screen turns blue, and then it will shut off. Okay, here we go, desktop. Hold on, let me pause it. Alright, we're on the desktop here. I want to show you this error that popped up here. It says Windows has recovered from an unexpected shutdown. Under the problem details, wasn't I just saying that? Blue screen of death. Okay, so I'm going to make an initial diagnosis here and saying that the hard drive is starting to go. So let me load up one of my programs here and make sure we can run a health test on this thing. Alright, so I've installed the program here. Let's go ahead and launch it. Don't worry about that message. Let's see here. So it tells me that the health status of the 1000 gig, the 1 terabyte hard drive, is actually good. It's good temperature. The power on count is a little over 3,000, which is normal. The power on hours is a little over 15,000, which is typical use. Don't worry about this information here, but I'm going to go ahead and spout it out for people that know. It's a SATA 600, and we are reading the smart information from the drive, and it tells me that it is healthy. That is interesting. Okay, so the next test that we're going to run on this is a speed test, which is going to tell me whether the hard drive is providing information to obviously the processor fast enough. Alright, let me pause this and we'll get that program installed. Alright, ladies and gentlemen, we are back. Let's go ahead and run a speed test on the hard drive. Anything around 100 megabytes per second is what we're looking for. And go. Oop, go ahead and focus here. We got 181 and 179. That is more than ample for this system. That is actually really fast for a physical drive. Alright, so we've ruled out that the drive is failing, and we've ruled out speed issues. So let me go ahead and get this thing to focus. So let's see here. Let me think about this. Let's do it live. That tells me that there is possibly errors on the operating system. And let's go ahead and check them then. Alright, we're back. I'm shutting the system down and I'm telling it to do a hard drive check on reboot. This will go through and check and validate all of the operating system files as well as the health, for bad sectors. I'll go into sectors at a later date. Basically the shelves of the hard drive to make sure we don't have any broken shelves for the files to not fall off of, but it's a metaphor. Alright, I'm going to pause it and wait for this to go ahead and start here. Alright, so let's go ahead and start. It's got 5 stages here, and this generally takes quite a long time. So I'm going to go ahead and pause the video and allow this to complete, and then we're going to find out what it finds. Alright, so we're part of the way through the test here. Feel free to pause the video and try to comprehend what's on the screen here. As you'll notice that the file verification process has completed. It didn't find any errors. Now is verifying the indexes. Index verification is complete. And now we are verifying the security descriptors. Wow, interesting. Never read that before. But we are on stage 3 of 5, and it normally starts to find corrupted files around the stage here between 3 and 4. And what corrupted files can do are wreak havoc on if a program goes to run and the file is incomplete, like the instruction set behind the file is incomplete. The program doesn't know what to do and it will close out. If enough programs do that, or for example the operating system, it will blue screen because the operating system is a program, and the computer will show signs of what the user described as shutting off. I don't think it is temperature related, because this test here, if it was CPU related, if the CPU was overheating, it would have already shut off. So for right now, I think we can dismiss that, and we're going to try to focus on the hard drive still and see what we can't really narrow this down. If this doesn't find anything, we're going to go into the operating system and see if we can't get more information on that blue screen error, time of day, etc. Get some more information on it. I'm going to go ahead and pause this and let this proceed. So, ladies and gentlemen, we are back. That test failed. It actually shut off in the middle of it. So I put my hand back here, and she's warm. So I might have been wrong about the temperature related thing. So let's go ahead and crack her open, and let's see what we're looking at here. Sometimes these screws are really tight. Try and do this one-handed. Oh, okay. Oh, yeah. We're a little bit dirty there. Oh, yeah, that's hot. Okay, let me show you what I'm looking at here. This is the processor heatsink fan. Underneath this is the brain. That is dirty in there. all the way down into the fins underneath. So, this pulls air across fins and it cools off the processor, and if it can't get air across the fins, the processor heats up, the computer freaks out and says I'm too hot and shuts down. That was the other reason, short of the blue screen of death, which we will make sure that hard drive is stable. So let's go ahead and, since I've just unplugged this, what I'm going to do is I'm going to go in the front and I'm going to hit the power button. That's going to discharge, there we go, all of the remaining electricity throughout the entire system, because it just tried to turn on and obviously it's not plugged in. So I'm going to go ahead and pull this off of here, and we're going to see what we're working with. Alright, I've gone ahead and pulled this out of the computer, and as you can see, there's a whole bunch of fins on the bottom of that. Hold it up to the light. Alright, so this fan blows air through here, and that connects to the processor down there. That's the brain of the system. That gets very hot, heats up this plate, and the air blows across here to cool it down. Well, when you're the bottom half isn't that clogged, okay, but focus here, there we go, there we go. She's dirty. So what we're going to do is I'm going to tear this apart and we're going to give this a really good bath, literally. So just to show you what was underneath of that fan, okay, this is solid with dirt. I can pick it up off of there. That is dander, cigarette smoke, cat hair, anything, any kind of particle that's floating in your air around your house. That's what you're breathing when you don't keep your air clean. Look at that. Okay, so let's go ahead and get this cleaned up, and I am 95% sure that our problem just presented itself and we can resolve this on the spot. Here she is, all nice and clean. You can see all the way through it. That's the way they should look. You can see all the way through it perfectly. Okay, now we just got to put this back together and put the screws back in it, and then we're going to show you something. We've got the fan put back together on the heatsink. Now, if you remember that gray paste that was on the bottom of that, that is essential. That is what is known as thermal paste. That basically glues the heatsink down to the processor. Without that thermal paste, this would be useless, pretty much. So, what do we got here? We've got some thermal paste. Come on, focus. No, I don't want to zoom. Stop it. Anyways, there we go, thermal compound. Okay, so what we do after the camera decides it wants to be the camera is we put a couple drops of that on here, and then we screw that back down, and we make sure we get a good good seating. So I'm going to go ahead and pause this and put some on. Alright, we're back. It might not look like much, but that's all you need is a little pea size, because the tolerance between the top of that chip and the bottom of this is so tight that when I go to put this down on there, it's going to squish out. So let me go ahead and do that, and I'll be back with you. Alrighty, sorry about the cutscenes, but there's not much to that. You just put the 4 screws in, and you do them cross corner, and you tighten down a little bit, until it eventually seats itself all the way down. You don't want to put one screw down all the way. You'll put it on you'll warp the motherboard and possibly break traces, and you do not want that. So I'll be making a disclaimer video about, you know, I'm not responsible for any damage that you do to your system. This was a reasonably everyday fix. So let's go ahead and make sure that solved our issue. Alrighty, ladies and gentlemen, welcome back. It's been a couple days since I've got to this because I've had other projects here, but I've got a final diagnosis on this system here. And if you notice a critical component missing here, this big box up here with all the wires coming out of it, that is the power supply to the system, and that's where your wall current comes in, and it changes it from AC current to DC current, and changes it down to the different voltages for the different components on the motherboard. We won't go into that right now. Well, I guess we will. Might as well. So, when the power comes in, obviously it changes it down to the voltages of what is known as rails, power rails. You have your 12 volt rail, you have your 3.3 volt rail, and you have your 5 volt rail. Well, the main plug for that is way down underneath there, and you have another one right there. Okay, and when it changes it down to the rails, the voltage rails, they have to be super strict on the variances in voltage. They cannot vary even 2/10 of a volt. Okay, they have to be dead on 12 volt, 5 volt, and 3.3 volt because these are super sensitive electronics in here. And let's just go ahead and show you an example of the power supply that I pulled out of here and what it was doing. Alright, first, this is a power supply tester. This little gadget here has saved my butt many times. Super cheap, only like 15 bucks down at Micro Center. Is well worth the purchase. Oh my goodness. It looks like I'm going to need another one. Anyways, let's try that again. So, one end goes in here, and it has obviously a module connection for different power supplies. Focus. There we go. Okay. 8-pin, 4-pin, and 6-pin. Anyways, so you've got your SATA, you've got your Molex. Anyways, you guys are just wanting to see this, so let me go ahead and hook this device up here and get some power to it. And pause. Pause. And we now have power to it. So, this little device here, 5 volts is exactly 5 volts. This is a good power supply. The 12 volt rail is exactly 11.9. The 3.3 is exactly 3.3. And so forth. The other 12 volt rail is exactly 12.1. 0.1 is okay. 11.8, that is a smidge low. The 5 volt is 4. I'm going to go with 9. I do need another one of these. Anyways, and the power good, that's how fast the power supply, just powering on basically. So this is a good power supply here. Unfortunately, this does not fit in that case because it is too big. There is different size power supplies. Different form factors, which is what they're called. So, let me go ahead and show you an example of one that is not good. And as soon as I turn the camera on, this one is the one that I pulled out of the system that was reading way high. I actually wrote overvolt on the side of it because the voltages were just stupid high. So let's go ahead and get this to focus here. Alright, see the 5 volt rail? It's 0.2. Even down there at the bottom we've got, there it is, the 12 volt rail is fluctuating. That's no good. 3.3 is good. 12 volt is within reason, but the other 12 volt down here, that's 0.2. That's right on the borderline. That's still too far out of spec. So this is the one that I pulled out, and she's no good. Okay, for the sake of demonstration, I had to go get this one out of the scrap pile. This one's all kinds of berserk. 4.9, then dropping. The 3.3 is way above. See it saying high, high, low, low, and then it's stable. It's all over the place. This is a perfect example. Look how high that 12 volt rail is. That is ridiculous. 12.3. Now the 5 is okay. Still fluctuating. That is way high. That is well out of acceptable range. Even this one here. 12.4. And then the 5 volt is not even 5 volts. That's dropping out. And then the 3 is going way high. So that's what a bad power supply looks like. And more in depth. Okay, where do we go from here? Well, we've got to run to the store because I don't have any of the older style power supplies that actually fit this model. This model is obviously an extremely old system, and as everything, they change everything across the systems. Not very much, just enough to piss you off so that won't fit. Um, yeah, here, let me show you the difference. Alrighty, there's the difference. This is the one that I pulled out, and this is the one that is actually good that I tried to put in, and yeah, they won't fit. So we got to go to the store and get another one of these and put it in, and it should be good to go. I tested it with this power supply, and it was stable for over an hour, didn't crash. I even put a stress test on it on the processor to make sure that it wasn't overheating, and I confirmed the diagnosis that the power supply was bad, and then I checked it with the meter, and lo and behold, it was fluctuating. So, trash. Good one. Won't fit. Story of my life.